Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this chemical equilibrium. In the previous video, we have discussed various factors influencing chemical equilibria, that is concentration, temperature, pressure, and then effect of addition of inert gas and followed by that catalyst. And apart from that, we have seen important aspect, that is Le-Chatelier principle, and then we have discussed regarding optimization of the conditions in the manufacturing of ammonia by Haber's process. In this particular video, we will see another type of equilibrium that we call it as ionic equilibrium in solutions. Okay, so ionic equilibrium in solutions, right? So prior to going for defining this term or prior to understanding that particular term, so we will take one experiment we will consider. Okay, so that we will see. Take two beakers containing water. Okay. To one you add sugar. Okay, and another one you add salt, that is NaCl you add, and you dissolve it. Okay, so then upon dissolution, what you will get? You will get the clear solutions of both sugar as well as salt. Okay, now what you do is, after that, you immerse an electrode. Okay, immerse the electrode and connect that with the battery. Okay, when you connect with battery, so then what happens, or any electrical source we can call. So here what happens, there is no conduction of electricity. Electricity is absorbed in sugar solution. When you pass the electricity, there is no conduction in sugar solution. Similarly, so there is a conduction of electricity. When you pass the electricity through NaCl solution, you observe there is a conduction of electricity. Okay, and that we call it as conduction of electricity. And apart from this, what happens? There is an increase in conduction also we will observe. Increase in conduction. Okay, upon increasing the concentration of NaCl is observed. Okay, so now based on these two behavior of solutions of different substances, okay, these are categorized into two types by Michael Faraday. And how we categorized these substance as into two types. One he called as electrolytes, and another one he called as non-electrolytes. Okay, it is being categorized by whom? So Michael Faraday. And what are these electrolytes and what are these non-electrolytes, that we will see. Okay. See, the compounds upon dissolution in water undergo dissociation to give ions are called electrolytes. Okay, the compound upon dissolution in water okay, gives clear solution but it will not ionize. ionize are called non-electrolytes. Okay, so example for electrolytes are your NaCl, common example. HCl you can take, NaOH you can take. Similarly here, non-electrolytes you can add example as your sugar solution. Okay, sugar, urea, etc. Now the question arises, why these sugars are not dissociating, why NaCl is dissociating? See, NaCl is an ionic compound. Okay, how it is being formed? A cation is being surrounded by anions, and anions are being surrounded by cations to form a ionic crystal, and they are held together by electrostatic force of attraction. Okay, and upon dissolution, those electrostatic force are broken, and independent ions we will get in the solution form. Whereas sugar or urea solution, if it is there, those compounds are covalent in nature and they are non-polar bonds are there. They won't dissociate in water. Okay, hence as they won't dissociate into ions, so therefore they won't conduct, and such compounds we call it as what? Non-electrolyte compounds. Okay, so now we will deal in detail with why these compounds are going to dissolve to give or undergo dissociation upon dissolution to give the ions. Okay, see what makes these electrolytes to dissociate. Say for example, you take NaCl is there, and NaCl compound occurs as what? These ionic crystal, generally we can take Na plus, and it is being surrounded by Cl minus, and it is being surrounded by Na plus. Okay, Na plus, Na plus. So like this, a cluster of oppositely charged ions which are held together by electrostatic force we can observe. Okay, and they form a strong ionic crystal. Now when you dissolve such compounds in water, how we dissociate? There must be something with even water molecule also, or with solvent also, so that we will see with water what it is there. See here, when you see the structure of water molecule, we see that there is a bond between oxygen and hydrogen, and there is a electronegativity difference between hydrogen and oxygen we observe, and that makes the covalent bond electrons more deviating towards oxygen atom, so therefore oxygen atom will carry partial negative charge and these will carry partial positive charge, and hence we call it as what? It has contains dipole. Okay, two poles are in the molecule, and it is having high dielectric constant, around 80 is its dielectric constant. Okay, and so this makes, or it can overcome the electrostatic force of attraction which keeps the ionic crystal intact, to break that one and get separated into individual ions. Actually what happens when you bring this ionic crystal in contact with water? Okay, so the negative end of the water molecule, okay, negative end of the water molecule right will surround the cation Na plus. Okay, similarly Cl minus ion is being surrounded by okay positive end of the water molecule, right? So that is how Cl minus ion is being surrounded. So as like this, what happens? They will get segregated from one another. Okay, and by that what happens? They will be free from one another. No more electrostatic force are keeping them together. Hence what they do, when you pass the electricity, so they migrate towards opposite terminal, and hence they conduct. Okay, and same thing, there is no dissociation or ionization. This we call it as what? Segregation of cation and anion. Okay, in that we call it as what? Ionization. Okay, so as they are being separated from one another, that we call it as what? Ionization. So now next important thing is, so these electrolytes are classified into two classes based on to what extent they undergo dissociation. They are grouped into two types, and that we will see. So electrolytes, we classify them as what? Into two classes. One we call it as what? Strong electrolyte, and another one we call it as what? Weak electrolyte. Okay, so this classification again given by the Faraday. So the compound upon dissolution in water, if it undergoes complete ionization or dissociation, we call complete ionization, are called strong electrolytes. An example, you can take NaCl, already we have discussed. NaOH you can take, HCl you can take, etc. Similarly, weak electrolytes are the compounds, the compound which upon dissolution in water undergo partial dissociation or ionization. Partial ionization we will take. Ionization give ions are called weak electrolytes. Examples are, you can take acetic acid, okay, all organic acids you can consider, or ammonium hydroxide, a weak base. These are all the examples of what? Weak electrolytes. Okay. So now interesting thing is what weak electrolytes, they undergo partial dissociation, means no complete dissociation as we see with your strong electrolytes. And let us define our ionic equilibria from this. Well, next is, we called acetic acid as weak electrolyte. Why? Because upon dissolution in water, it undergoes partial dissociation. Aqueous plus H plus aqueous. Okay. So, say for example, around there will be greater than 95% will be your acetic acid form upon in dissolution in water, and less than 5% will be your dissociated form. Okay, and one thing you should remember, there is a dynamic equilibrium between undissociated acetic acid and dissociated form, that is ions, acetate ion and H plus ions. Means continuously there is an exchange of these two, okay, at equilibrium we see, hence we call it as dynamic equilibrium. So this we call it as what? Ionized form. Ionized form, and this we call it as what? Unionized form. Okay, acetic acid, water, it is unionized form, and here acetate ion, H plus ion, aqueous. So they are ionized form we call, right? Because they are segregated. Now, a equilibrium as it is being established between these two, and this equilibrium between unionized and ionized form is called ionic equilibria. Okay, or ionic equilibrium in solution we call. Okay, let us define this one. The equilibrium between ionized and unionized form of a compound in aqueous medium is called ionic equilibrium. Okay, so that is nothing but what? Ionic equilibria. So apart, these strong electrolytes are not going to establish any equilibrium, but weak electrolytes are going to establish equilibrium, and you will be finding ionized and unionized form. And the equilibrium, dynamic equilibrium between ionized and unionized form, we call it as what? Ionic equilibria. Okay, I hope you have understood the definition of electrolytes, non-electrolytes, okay, strong electrolytes and weak electrolytes, and how these weak electrolytes are going to establish, are going to attain an equilibrium, and that equilibrium we are calling it as what? Ionic equilibrium. Okay, and in the next video, okay, we will discuss regarding acids, bases, and salts in detail. Okay, please don't forget to subscribe our channel. Thank you for watching.